Good afternoon, everybody. Welcome back to lecture number 24. We are in week 8, and last time we finished the V over F control, and I told you this is very important for the quiz. If I want to do this example, can I do it from the table? Yes, I can do it from the table. صح ولا لا? So if you go to V over F control and you have a constant, so V over F, basically it's V1 square S1 F2 over V2 square S2 F1 equal to 1. So in the example, we had to find, I think, S2, and then we already know V2, V1. And if you fix, for example, no, you want to calculate S2, okay? So you may try to use this equation. It may work, okay? Because in the example, what did we do? In the example, we calculated the slip. Where is it? We calculated the slip using the torque, okay? And then we calculated the omega, and then the example was talking about starting torque, okay? So make sure you do this example and you understand the table if you have two operating conditions, okay? Clear? Clear? So the example was talking about starting current between two operating conditions, but I may ask you to calculate using the equation V1 square is 1 F2 over V2 square is 2 F1 equal to 1. So what will happen, maybe part C, what will happen if, find the slip if I increase the voltage by this number and the frequency 2 by this number, and you know V2 over F, they are the same. You may find slip is the same, the slip is changing, I don't know, something like that, okay? But for now, focus on the example. It's what really matters, okay? I didn't write the quiz yet. So enough about control. So we're done from the 6 control techniques, okay? The two important ones are slip energy recovery, if you want to control the wound rotor, and the V over F, which is the majority of induction motors, if you have squirrel cage, or if you want to apply your control from the stator. The vast majority of control schemes, they use variable speed drives, and it uses V over F directly. Okay? So V over F, I can say, is probably the most important way to control the vast majority of induction motors. Now, let's tackle some problems. The first problem is starting of 3-phase induction machines. For direct start, what does direct start mean? ايش معنى direct؟ There is no variable speed drive. So if you connect it directly to the wall, you don't have V over F control, you cannot reduce the starting current. You can't control it. Because one of the advantages of V over F is you fix the starting current. Usually the starting current that is allowed is 5 to 7 times the rated machine current. So you can estimate, if you don't know how much current the machine, just look at the rated current multiplied by 5 to 7, and then you can estimate roughly how much the impact on your system. This is a quick way. So when you work with Aramco and you buy a motor, you tell them, you ask the operations, hello operations, we expect to have 5 to 7 rated current at the start. So are you prepared for that? Clear? So do not buy a machine that consumes more than 7 times of the rated current. And then it's based on the loads. Usually, the bigger the machine, they already come up with tests for that. The company that sells you the machine probably will do assessment test on the loading conditions at your facility. The surrounding loads are affected by suddenly voltage drop, and it may be tripped. So for example, your breakers may trip, your relays may trip. So this is one of the consequences. So one of the solutions is reducing the starting current of the induction machine by assigning the slip equal to 1, and you can calculate V phase over square root of the summation of R's plus X equivalent squared. When you do these calculations, you notice that adding resistance can also be used to reduce the starting current. So adding resistance has two advantages: speed control and reducing starting current. Or increase the supply frequency at the starting. This is one of the techniques, is before you start your machine, you increase the frequency because X equivalent will be larger. X equivalent will be larger. Now, it comes with a cost. If you increase the frequency, your starting torque becomes low and your maximum torque drops. So that's why you have to do V over F, limited by Firas, V rate. Okay, limited V over F is limited by V rate. And you may also reduce the starting voltage of the machine. So you can control the V, the R2 prime, which can be added. This is only for wound rotor, and its equivalent. So considering the starting torque, do you remember last time I told you maybe some of the application you want to have your torque lower than starting torque for applications like the elevator, for example. If you want to elevator, this is class C or class D. Remember class C or class D where we make this up? So for constant torque application, such as elevators, you have to make sure that your starting torque is larger than your load, your constant load. So if we use the approximated circuit, we can estimate the torque to be 3V1 squared. V1 here, is it phase or line? Phase. So we use V1 or we use the symbol V phase. You have two symbols for V phase. And if pure V, what does it mean? Line to line. Okay? You need to get used to different rotations. Khalas, you are seniors. No more E to O1. So the starting torque can be calculated by assigning slip equal to 1, the slip equal to 1. Remember we did the approximations. If we do the approximations, you may reach this equation, 3V1 squared R2 prime over X equivalent omega S. Okay? As we can see, the constant load torque needs a starting torque higher than the load torque value to operate the machine as per the dynamic equation, swing equation, where TE is the machine electrical torque, T load is the load torque, J is the motor inertia, and omega is the motor speed. So that's what I told you. Starting torque has to be larger than the load for various applications. Maybe in one application you may start, especially like linear load, or fans, you can start at small load. And think with me, can you spin the fan with the minimal torque? عندك fan. Can you spin it with your finger?
Yes.
Yeah, so the starting torque is small. Now, let's say you have a hoist back up. Can you pull it with your finger? No. You need to pull it strong. So this is one way to assess the starting torque. Okay? The wind turbine, starting torque, is it low or high?
Low.
Low. Because this is fan load. So you get a sense now between different types of loads. So that's one of the things. Last time in the class I tried to plot, and I think I made mistakes. My plots were starting lower than the starting torque for a constant load. Constant load means you have to start higher than your constant load. So this is a question maybe in the quiz. No, not in the quiz. Maybe in the exam. Can you start a constant load with a starting torque for the machine lower than the starting torque?
No.
Okay. Can you start a fan with a small starting torque?
Yes.
Clear? واضح الدفرنس؟ So when you add the resistors, what will happen?
Shift.
Remember, in the slip ring, we add external resistors, we change them. What will happen? Still شغال؟
Yes.
So, this method is valid only for what? Wound rotor. So, squirrel cage IMs, not applicable. Okay? And the vast majority of your motors are what? Squirrel cage. In case of squirrel cage rotor, the rotor can be redesigned as deep bar or double cage type. This is the solution for squirrel cage. So, a rotor bar has to be redesigned to increase the effective resistance for such application. So, this is in EE360. I think some of the classes talked about it. Some of the classes did not talk about the double cage thing. What are the advantages? We increase the starting torque. So here, as we increase the resistance, remember this was, we changed the class. So as we increase the external resistance, our external increase, your starting torque increases. Okay? Maximum torque can be obtained at starting. So you can shift this peak all the way to start. The added resistance required to make maximum starting torque is calculated using this equation. So this equation, R2 prime plus R over X equivalent square plus R1 square equal to 1. This is, I think, S max. Is it the same one in E360? ولا مختلفة? Who has a cheat sheet? Anybody has a cheat sheet? I think this equation is a little bit different. No. It's R2 prime, originally. It's R2 prime over square root of X equivalent plus R1. Here you add R added. Okay, and then you do the calculations. So maybe this is a simple question. How much R added to make the slip equal to 1 at start? Okay? We already covered a little bit this concept. So when induction machine starts, we already talked about it. It draws a current 5 to 7. A voltage drop occurs at the load may affect surrounding loads and cause under voltage relays to misoperate. The solution for this is to smooth start the machine, start reduce voltage, adding resistors, current limiting. This is the same slide, but it's written in a different way. Now, one of the solutions is, we said add resistor, but one of the other things is reduced voltage. How can I reduce the voltage? So let's learn few tricks on how to reduce the voltage for starting of the machine. Okay? So solution 1, adding resistance. Solution 2 is reduce the voltage. And what was solution 3? وين درجة التحضير؟ L. Okay. Do you remember what was the previous slide? So we said increase supply frequency at the start. Increase supply means you use variable speed drive, okay? So the two slides are the same. The last thing we'll talk about is variable speed drive. So we talked about the adding resistor. This is variable speed drive. So we still have this. So now we're doing this. Solution is start with reduced voltage. Using what? Auto-transformer. Do you remember the auto-transformer?
Yes.
What is the auto-transformer? Auto-transformer, you remember from EE360, and I think last semester, whoever took EE360 last semester, it was removed. Okay? Auto transformer was removed. So auto transformer is just a transformer, but you get access to a portion of the windings. Okay? So here, for example, what? N primary, and here you have V secondary. V primary, V secondary. So N primary is actually NS plus N, I don't know, E. So NE plus NS is N primary and NS is the small one. The idea about it is it uses a single coil. It doesn't use two separate coils like the regular. ايش معنى auto؟ يعني واحد. Okay? Clear? You remember the auto transformer? So let's see. So at the beginning, what we assume is to reduce the voltage, I start here, I get the voltage from here. After some time, I get the voltage from here, I get higher voltage. Okay? Now this is connected to the supply. So at start, I just I run my motor here, then I reconfigure my breakers to connect the motor here. So let's see how it looks like. I have 3 coils. Why I have 3 auto transformers? For each phase. So here we have contacts. R, S. R means running contacts. S means starting contacts. So at the start, close the S, open the R. So you connect your induction machine. Where is it? S is closed, so if I close this S.
وانت تشوف البرايمري وال
بس هذا في الفيز B و C. Okay. Phase B و C they are connected. أنا بس أبي أشوفها. Is this a jump or connection? This is a jump. This is a connection. Okay? Jump يعني these two cables jump each other. So phase A will be connected to this voltage and will be connected to the common. This is the common. So what is my voltage? That appears only this portion of the coil. Clear? At running, I close this. I open that. So what is my portion? Full supply. Because I short this coil. خلاص هذا open. The auto transformer is disconnected. So I connect directly to supply. Clear? Can anybody explain it?
انه في الهدف بالبدايه ان نحط فولتج قليل بعدين لما تصير رننج
طيب
نشبك السبلاي كله.
تمام. Good. So الفولتج القليل هو the voltage across this coil at start. So you get your supply voltage هذا هنا. Clear? You connect the auto transformer as supply. At run, remove the auto transformer. No need. Ignore them. You directly connect as supply. Clear?
Yes.
But this doesn't give you variable voltage, right?
No. Auto transformer doesn't give you variable voltage. This is just to start at a small voltage.
So we are not using any of the previous techniques. Yeah, this is
No. The major, okay, to reduce the starting torque, increase the resistance, reduce the voltage, change the frequency.
So this is just this.
A resistance, we change it by external resistance. You may use the chopper, اللي درسناه قبل. You may use the chopper that we started earlier. Do you remember before we talked about the choppers?
AC controller, AC voltage controller.
Before, long time. We talked about talked about. Do you remember this chopper with control? We reduce the effective resistance. This is the practical way, okay? Because it doesn't make sense you bring a resistor, you connect. No, it's better to have one resistor bank and you chop from it. You connect, disconnect, connect, disconnect, okay? Using the means of contacts. The other thing is we talked about, if you remember, we talked about the AC voltage controller, the AC chopper. And this one using a thyristor, the other one uses a pulse width modulator. The idea here is to reduce the effective RMS based on opening the gates. We're not going to talk about the pulse details. I'm not going to ask you plot VG. This is power electronics. But understand the concept is AC voltage controller can be done by auto transformer and also can be done using AC choppers. AC choppers have different shapes.
This gives you control.
This gives you voltage.
Transformer doesn't give you control.
You are right. You're right. Okay? So the auto transformer is just low and high. خلاص. The other method.
طيب ما اقدر اتحكم بالعدد الوايندنج اللي قاعد اخذها.
No, this is tab changing transformer.
ايوه لو كان
Tab changing transformer.
ما ادري هو كذا.
There is a tab changing. There is another type of auto transformer fixed.
Okay.
There is another type of auto transformer that has variable tab. Some of them have 5%, 5%. Some of them have all full axis. It depends on the auto transformer. Here we're assuming the auto transformer is fixed. Usually the tab changing transformer comes with an arrow. حط لك سهم.
يكون في اكثر من ليفل الاول اللي كان.
Yeah. So here we're making it simple. We're using fixed auto transformer. So let's read the text a little bit. Partial voltage will be applied, then full voltage will be applied at steady state. Technique requires contactors with timers. This is old school. Okay? Another smart way is, did you ask yourself how they change Y and delta connection in industry?
وقف ماشين غير
That's not efficient. This is the Y delta switch. There is a switch to change the Y to delta. As all of you know, and if you don't know this, please let me know. Y voltage is always smaller than delta by a factor of 58%. 1 over square root of 3, or 1 over square root of 3 will give you the ratio of, no.
نتكلم على لاين على
كم جذر 3؟ 1.7.
1.7.
So what is 1 over 1.7? 58%. What is 1 over جذر 3?
58.
So 58% you can reduce the supply for 80 by 58% if you connect it Y. So at the start, connect to Y. During an operation, connect to delta. How to do this without messing with the wires, like what you do in the lab? In the lab, you mess with the wires?
Yes.
So how to do it? There is another technique said we can reduce the starting current by using Y delta. This method is only limited to desired delta motors. And can you use it if you plan to use the motor in the Y form, in the Y connection?
No.
No. If you already plan to use delta, if you already plan, يعني already فتك في plan, your motor operates for delta, you may start it as Y, and then switch to delta using this switch. How this switch operates? You have 1 and 2. If you connect to 1, it becomes to 1, 1, 1. It becomes إيش? Y. 1. This is a jump. This is a jump. So if you connect 1, 2, 3. You see it? This is a 1. At 2, you connect this in series with this, in series with that, using timers and contactors. Okay? Now again, this is old school method. And what is our favorite method? Power electronics. We use AC voltage controller. That's the smart way, or AC chopper. This is back-to-back converter, variable speed drive. 2 different converters can be used. AC chopper, back-to-back, it's a rectifier and inverter. This is called VSD. Or we can use the AC chopper that we studied before. How many shapes of AC choppers we have?
2.
2. One using 2 thyristor, one using
Pulse width modulation.
pulse width modulation. Okay? Or you use the favorite. What is the favorite?
Back-to-back converter.
VSD. This is VSD. This is your solution. Okay? Did you buy your inverter?
I don't need.
Didn't you? Who bought inverter for the senior project? You bought it?
Yeah.
What is the application?
Testing gearboxes. So different speed, different loading conditions. For the motor.
What type of machines did you use?
Induction motors.
Induction. So did you apply V over F there?
Not yet. Still working with that problem.
But doesn't come with, it's not already programmed, the inverter. You just control it by,
داتا شيت من صفحة هذا.
wow. Use VSD. Okay? So starting by reduced voltage reduces the starting torque, hence the value of the starting torque has to be considered in the design if the load constant is there. Constant load, starting torque has to be high. Okay? So be careful, don't be tricked. Yes.
Previously, when we had constant torque, we called the graph a fan load. But it doesn't seem to be applicable here. I'm not sure.
Which lecture?
You put the 3 graphs for the torque, the constant torque, and torque equals omega, and torque equals omega square.
Yes.
And I think you called the torque constant a fan load.
In the lecture?
I'm not sure. Maybe you called it different one. I just want to understand the justification.
Okay. No. Here is the thing. A constant torque is at a small speed, you need to apply 150 Newton. Okay? Even at very high speed, if your elevator is even fast, it still has to still has to maintain the 150. Because if you apply higher torque, your elevator will move. No, it will be snapped. Okay? It has to be fixed. The speed has to be constant. But before it stops, so let's see that this is the elevator speed, the design. It would accelerate until it reaches the elevator design, and then it will maintain its speed constant. And throughout the whole process, the torque has to be 150.
طيب كيف تسوي كذا؟ الكارب يكون شكله.
يا أخي بالفيزياء 101. When you push a box from start, you push it at same torque,
طيب.
and then you stop. Throughout the operation, you assume the torque applied to be 150.
إيه بس الكارب يعني اللي درسناه يكون التورك versus speed يكون شكله.
This is mechanical engineering. This is modeling. It's it involves dynamics. So maybe the whole assumption constant torque is not realistic.
I think the fan load was the torque equals omega.
No,
Or was it not?
the fan is omega squared.
It was omega square. Okay.
The other one is omega, you start from here. Maybe because what I'm saying is, at small speeds there is no torque, but after a certain speed if you increase the speed, the torque will increase linearly.
Okay.
So if you want, this is some types of loads. If you want to, يعني, think with me.
Acceleration maybe. Or
You push the table
linear.
بعدين تندف. اوكي؟ بس اذا اندفت اذا ابغى ازيد السرعه التورك يزداد خطيا معها. اذا ازيد السرعه التورك يزداد خطيا معها. The last type is the omega square. So you really start here and then it skyrockets. If the fan is spinning at this speed, to increase its speed a little bit, you have to apply very huge increase in load. Up until you reach a very high speed, you can't push it faster. You have to really apply huge thrust. Think of the airplane. That thrust would generate so much torque to increase the speed to these gigantic limits. But at very small speeds, the fan would spin easily.
Okay.
This is mechanical modeling, okay? Usually there is always three types of loads. And always your motor. So if you have the same motor, you connect different loads. If you, for this capability curve, if you connect a constant torque, you're operating at linear region. If you connect a fan or the linear torque, you're in the unstable region. So you have to change the control of your motor to cross it where? In the linear region. In other words, three different loads require three different completely controlled parameters. Is it clear now?
Yes.
And how to do it? You go to the table. So for example, if I ask you in the quiz for all the examples we did linear, صح?
Right.
So focus on the linear. If I ask you in the quiz, no, not the linear, constant. If I ask you in the quiz, you're operating at 440, 60 hertz, at slip 0.02. How much the slip needed to operate at 450 hertz? Clear?
Yes.
You just calculate S2. This is a simple question using V over F for a constant load. Now, if you operate a linear load, you have to solve this equation as function of S2. So here you have S2, here you have S2, so it's quadratic. If you have a fan load, here you have S2, here you have S2 squared, so it's to the power 3. You have to solve the equation in the power 3. Do you want to see this equation in the final? Measure 2? That's why we're doing Wiley constant. Okay? So today we covered, what did we cover? Let's review it. We covered the starting three phase. We said the starting current is always 5 to 7. Anything higher is bad. And if you know nothing, assume it's 5 to 7. If you know nothing, and when you do planning, did I tell you about my first job? What was my first job? I didn't tell you. So my first job, I was a planning engineer with Aram. Literally, they asked me to go and buy a pump for one of the facilities. I didn't know stuff because I didn't take 462. I was scared. Well, I didn't take 462. I regret it. Now I'm teaching it. So 462, if I took 462, I would have known how to size the pump that they asked me to get a quote for. Okay? So this is a true story. I still remember the pump. I think it was a bypass pump. And they already have a pump. They want to reroute the pipeline to have another pump. So if you reroute, you get different pressures, huh? So you can't buy the same pump. And what's a pump? Pump is a motor. A pump is nothing but a motor. Now who loves Schlumberger? SLB. So when you work with them in the remote area where you get paid very high money, you will work with the petroleum engineer in the pump because you took 462. So pumps are everywhere. And one huge problem in oil application in the remote area is they don't have grid. They don't have 60 hertz. And most of the VSBs are designed to operate with the grid. So there they have their own generator. And if you have your own generator, you get power quality issue, and then the variable speed drives do not work, and then the pump doesn't work efficiently. So it is a very hot topic. 462 is present in the remote oil field. Okay? And also we talked about the starting torque. We said if you want to reduce the starting current, you have to reduce the starting torque. And how to do that, how to get the both benefits is you add the resistor, or you reduce the voltage using one auto transformer, two for delta planned up motors. Only you start as Y and then connect it to delta, or you use your favorite, VSD. So if you know nothing in the test, what is your solution? Variable speed drive. Okay? It helps. It solves all the problems. Or the AC choppers. How many types of AC choppers we have? Two. The first one is thyristors. How many thyristors? The second one is
4.
PWM. Using,
4.
is it what, diode?
كان 4 توقع.
Switches. Transistors.
Transistors? Okay. Now let's talk about the braking. What is the braking of induction machine? Braking is not hitting the brake. Don't think about braking is reducing speed. In electric motors, braking, one of it is just reducing the speed. But braking has too many things in the electric motor. So let me start with introduction. فحمات حقت السيارة, the brake paddles. Which one degrade faster? EV or regular? The reason is because when you hit the brake in EV, you're not actually hitting the brake unless you really need to for emergency application. You're usually hitting the electric motor controller rather than actually reducing the speed of the tires, directly hitting the tires. So there is applications. There is two different things, or not application. There is instance when you operate your induction machine. The first one is rapid stopping. Rapid stopping is a form of braking. Another thing is holding the rotor shaft at a specific position is also braking. Think about the crane. So when the crane carries the thing and it holds it, is the craning operating at braking mode or non-braking mode? Brake. This is also considered braking. The third application is maintaining a motor speed at a desired value. That's also braking. Preventing the motor from overspeeding, that is also braking. So we all now know braking is not only reducing speed or rapid stop. It includes rapid stop. It includes holding the rotor at a fixed position without any movement, zero speed, that's a braking. It includes maintaining motor speed at a desired value or not, preventing it from overspeed. All of these are braking. All these aspects of braking are done electrically without any mechanical, physical brake. This is all electrical. During the braking, the mechanical load is considered as source of energy. So during this braking mode, your mechanical movement can be used to generate electricity for regenerative braking, for example. I'm not talking about the third, I'm not talking about this curve.
Generating mode.
No, I'm not talking about it. This is different. we're not talking about the mode. We're talking about operating modes. There is 3 operating modes. What are the operating modes?
Plugging, motor, generator.
Motoring mode, generating mode, and plugging mode. 3 of plugging can be in any one of them.
Braking or generating?
No, braking can be in any one of them. Braking has nothing to do with the mode. Braking is one of those 4 things that I mentioned. Braking is one of the 4. Either rapid stopping, either holding the rotor shaft at specific position. What's the speed? 0. So this is between motoring and plugging. Maintaining the motor speed at desired value. This can be in motoring, this can be in generating, we don't know. Preventing the motor from overspeeding, this can be in motoring mode, this can be also in generating mode, this can be even in plugging mode. It has nothing to do. During the braking, the mechanical load is considered as the source of energy. The accurate and fast braking method is always preferred. It has to be accurate, it has to be fast. Think about robot that must be able to stop, hold the position, and reverse direction with high degree of accuracy. Accuracy is very important. 3 different types of braking. The first one is regenerative braking. The second one is dynamic braking. The third one is counter-current braking. We'll talk about it next lecture. Okay? What do you think regenerative braking, which mode of operation? Generating. Okay? So braking has nothing to do with the mode. Braking is a status that requires certain control with accuracy and fast response. Okay? So we'll talk about regenerative braking next lecture. Any other question? Okay, stop the recording. Feel free to go.